Welcome to another episode of The Elements, a visual exploration of every known atom in the universe. Today we are starting our exploration with antimony. Alright, with antimony, antimony is not anti-money. It's not there to just prevent you from using your money. It just doesn't want you to lose sight of all the other things that you could be working on. Whether it's your lifestyle, your antimony is typically a metalloid, which is clearly metallic in appearance, but yet quite brittle and more crystalline than other ordinary metals. Adding antimony towards lead makes the lead much harder, and once you do that, it will work out a lot. And antimony has the wonderful property that it just expands, just like as a tiny bit, like from a solid device and from a molten state. It will just expand so much and so quickly. Linotype machines may be fading from memory, but another application of this antimony is that lead-antimony alloys remain as popular as ever inside weapons. Bullets. Bullets are famously made of lead because, well, they use up so much less space, but pure lead is too soft, so antimony is added to make sure that the lead is hard enough to at least pierce something. Lead-acid car batteries use lead electrode plates that are similarly hardened with antimony. A lovely property of antimony that the author himself has not seen ever reported anywhere else is that blocks of it emit apparently beautifully melodic pinging noises after being cast. I'm not sure if that's true, though. Its atomic weight is 121, its density is 6.697, its atomic radius is 133 picometers, its crystal structure, it's an oblong cube, and it's starting to fill up 5p. In the end, though, it's just like that. And next up we have tellurium. Tellurium is the most beautiful element name, according to the author. It's from the Latin for earth, has a poetry unmatched by any other, and apparently the author has some special fondness towards its name. When a company was planning to publish a computer game named Wolfram, creating a potentially trademark problem for his own software company, Wolfram Research, he was able to defuse the situation by convincing them that tellurium was a much better for their game. Wow. He loves Wolfram a lot. He loves tellurium a lot, which really is kind of a beautiful name too. It's one of the best. It's one of the best ones too. It may have been a pretty name and a very pretty crystal structure, but this element's properties make it quite anything but pretty when you meet it. Exposure to very small concentrations cause you to smell of rotten garlic for weeks. A fact that for reason limited early interest in the research for the substance. That's the only reason why people haven't researched it that much. It has a number of different applications, and well, there is a lot. You might have some in your house right now if you have a form of tellurium suboxide, which is the magic layer in DVD RW and the Blu-ray rewritable discs. Yes, they are in DVDs and apparently CDs, and I have a bunch of those in my house. Yeah, when you combine this extreme rarity with use on some popular disk formats and solar cells, you will be able to use some experimental memory chips as well too. And some people predict an explosion in tellurium prices. Once you add that in there, well, tellurium will become very expensive. And it does have become more expensive. Its atomic weight is 127.6, its density is 6.240, its atomic radius is 123 picometers, and its crystal structure is a hexagonal prism. And it is starting to go up, and its melting temperature, it's kind of low. Alright, next up we have iodine. Iodine is most famous for being used in inks. As you move down the halogen columns, the elements mellow a bit, from vicious fluorine to deadly chlorine to barely liquid bromine until you reach iodine. An element so comparatively benign that, well, you basically don't really have much use for it. That is used to cure hoof funguses in horses. Iodine is kind of like that too, except there's another practical use towards iodine. You use it in ink, and iodine dissolved in alcohol has been a disinfectant for generations. Yes, you use it as disinfectant. And pretty much that's all else too. For some reason, it's also put inside chewing gum. Deliciously flavored, contains iodine. Iodine, usually in a few forms, is also put into alcohol. Dissolved in alcohol, which causes the stinging. The alcohol is the thing that causes the stinging, not the iodine. Was once widely used as a disinfectant, until this is limited, mainly because iodine is kind of suspicious. But we still kind of use it like chlorine. It goes ahead and cleans up and disinfects things by brutally chemically attacking it. It has 126.90447 and its atomic weight. It has a density of 4.940. Its atomic radius is 115 picometers. Its crystal structure, it's cuboid, and it has, well, not much to really talk about. Mainly though, it does have a really low melting point, and it's a really low boiling point too. And then we have the least noble of the noble gases, xenon. Xenon itself, for most practical notices, it's noble, it's inert, and it's non-reactive, and just like other gases in the noble gases column of the periodic table, is one of the most expensive. But in what you can just go ahead and describe this as an egregious case of slumming, in 1962, xenon was caught in the act of forming compounds with common elements. And that's something that noble gases are not supposed to do. Since then, dozens of xenon compounds, usually involving fluorine, have been discovered and prepared. Xenon difluoride, for example, is commercially available from any laboratory catalog. It comes in a bottle just as plain as day. Wow, that's great. This is really shocking because, it isn't supposed to do. It simply isn't something that noble gases are supposed to do. You're not supposed to go ahead and combine with the little things. It's the least noble of the noble gases themselves. However, the central problem in cinema projectors and spotlights is creating a parallel beam of light, so that's why xenon comes in. Xenon goes ahead and helps IMAX projectors use a fantastically bright 15 kilowatt xenon short arc lamps to create their huge projected images, and that's how we can do this. And so that is xenon, and we have to move on. It has an atomic weight of 131.9293, has a density of 0.0059, has an atomic radius of 108 picometers, and its crystal structure, it's a cube. It's a really, really, really low melting point, and in fact, even a just slightly higher boiling point as well too. Finally, for the day, we have cesium. Cesium is widely listed as the most reactive of all the alkaline metals, and technically it is. When you go ahead and you put it into, if you drop a piece of it into a bowl of water, it instantly explodes, sending water flying in all directions, but that doesn't mean it makes the biggest explosion. So, sodium, it takes longer to explode when tossed in water, but while you're waiting, the plume of hydrogen gas is there, and well, as it happens, it just goes ahead and booms, makes a huge plume of hydrogen gas, and that hydrogen gas ignites, creating a huge explosion of molten sodium. Well, apparently not for noses, because he spent a few days throwing alkaline metals into the lake. Well, yeah. To show how dynamite can be improved by using cesium inside of there, they used an explosion to match what they expected from its technical reactivity, and that's pretty much what happened towards the author, who was doing it for British television. But the main business of cesium is that not its explosions, it's time. The current official definition of the second reads as follows. The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. Obviously, that's kind of the standard practice, and so it is the element of atomic clocks. It's very precise of a second, and so you can use it to create a clock. There are no stray electromagnetic materials in some of the things that it creates, and a piece of solid magnesium metal can float on concentrated cesium form a solution, so you can just go ahead and make an oil well drilling machine too. A cesium getter, when you activate it by heat, it would clear the last traces and oxygen and water from a vacuum chamber, which is really useful. Powdered cesium formate is even used in oil well drilling, and that's all I can say for cesium. So that is the end for today. Its atomic weight is 132.90545. Its density is 1.879. Its atomic radius is 298 picometers. Its crystal structure, it's a cube, and it has a pretty balanced amount of things. 5P is finished, and 6S is being filled now, and that's it for today. I hope you guys enjoyed it. I'll see you guys soon. Until next time, Nana, peace. Bye bye.